Alright everyone, so today we're going to be going over local extrema of a function, relative minimum and relative maximum to be exact. So I'm going to go over two ways to do this. The first is the first derivative test and the other one is the second derivative test. So we're going to go over the first derivative test first, and that says that if f prime of x is greater than 0 on an open interval to the left of your critical point and f of prime is negative to the right of that point, then f has a relative maximum at that point. So it might sound a little bit confusing, but if you put it on a number line and really visualize what it's saying, it actually becomes very simple. So here's our number line, here's x naught, and so what it's saying is it's positive on the left. Just some pluses here, positive on the left, and then negative on the right. Decreasing on the right, I should say, because we're talking about negative slope. The function is decreasing. And so then if you draw the function, it's increasing here, levels off at x naught, and then it starts being negative. So then here, obviously here's your maximum point. And rule B of the test says that if, it's pretty much the opposite of part A, if we're negative on the left of the point and positive on the right, well, then we have a relative minimum. So let's go ahead and see what that looks like. Negative on the left and positive on the right. Draw a negative slope here, negative, then positive. Then here you see this is obviously your minimum. And then the third rule stipulates that if you have the same side on the same, if your derivative has the same sign on either side of your critical point, then it's neither increasing or decreasing. Yeah, so if it's negative the whole time, it's going to look like this, and obviously there is no relative minimum. And same is true with the positive slope all the way, it just continues to increase. So we can't find a relative minimum or maximum in that case. So that's what the first derivative test tells us. Okay, so obviously if we're going to use the first derivative test, we need to take the first derivative. And derivative of this is 6x squared minus 6x minus 36. So now we need to solve for critical points, or x naughts, in another word. And so we're going to set this equal to 0. And we can factor out a 6. This happens to be really nice. Minus 6, and then 36 divided by 6 is 6. And so we factor this, and we find that x is x minus 3 times x plus 2 will make this 0. And we can simplify, finally solve it, and so we have our critical points here. X is 3 and negative 2. So now we can come over here and modify our line here. So now we know that our critical points are at negative 2 and 3. So we're going to figure out the local extrema, a relative maximum if there is one, and a relative minimum if there is one. There might be one of each, there might be neither. So we don't really know yet. We have to analyze this first. So we have to plug in values into the derivative to see if it's positive or negative. So we're going to do something in between of negative 2 and 3, which is 0. So we plug in 0 to this function. 0 squared minus 0 minus 6. You get negative 6. So we know this is decreasing. Now let's try something greater than 3. Let's try 4. So we'd have 4 squared, 16. 16 minus 4 minus 6. So 16 minus 10, we're at positive 6. So that means this is positive here. Okay, now let's do something smaller than -2. Let's try -3. -3 squared is 9 minus a -3, which means we're adding 3. So it's going to be 9 plus 3, 12 minus 6, positive 6. So we're going to add. That means that the derivative is positive. And therefore the function is increasing for x value smaller than -2. And we can draw a little graph here, like a guess of what the function might look like. So it's increasing, starts decreasing, and then once we get to x equals 3, we start increasing again. So now we can say what our critical points are by looking at the first derivative test. So if f is positive on the left and negative on the right, we have a relative max. That means that x equals -2 is a relative max. And it makes sense because if you look, this is the highest point on our little graph here. And then if you look at x equals 3, well, if it's negative on the left and positive on the right, then you have a relative minimum. And yep, this is the lowest point on our little graph, so it makes sense. So f has relative maximum at x equals -2. F has relative minimum at x equals 3. Okay. And so now I'm going to show you the exact same function just with a different test. And so sometimes what happens is the first derivative test won't work. So you have to use a second derivative test, or vice versa. The second derivative test doesn't work, so you have to use the first derivative test. I think the second derivative test is actually easier because in the first derivative test you have to plug in a bunch of numbers and test them and then make your little line here. But this one, second derivative test says that you plug in your critical numbers to the derivative, and if you get 0, then you can use the second derivative. And all this means, if f prime equals 0, that means it's a critical point. So we know that this first criterion is already true. And then if the second derivative at that point is positive, you have relative minimum. If the second derivative is negative, you have relative maximum. And if the second derivative equals 0, then you cannot use the second derivative test. That's when you'd have to use the first derivative test. So we already know our first derivative, 6x squared minus 6x minus 36. Now let's go ahead and take our second derivative. It's 12x minus 6. Alright. So we know this first criterion here is all true. So now all we need to test is the second criterion to see if it's positive or negative, pretty much. So let's go ahead and plug in x equals -2. So here we have -24 minus 6. It's a negative number, which means that, so what happens when f double prime is negative? It means it's a relative max. So that means f has relative max at x equals -2 by the second derivative test. And so this showed that f has a relative max at x equals -2. We can check our work here and we say, oh yeah, it's consistent. We have the same answer over here. And so hopefully the second derivative test will tell us that x equals 3 is the minimum. I'm sure you can already see at this point that we're going to have a positive number, 36 minus 6, but a positive number. let me try it up here. That was negative. Now we get a positive number, and when the second derivative is positive and the first derivative is 0, well, then let me do a relative minimum. F has a relative min at x equals 3 by the second derivative test.